Have you ever found yourself stuck in a traffic jam, just staring at the brake lights ahead and wondering, who on earth designs these road systems? Well, the answer isn't just about pouring concrete. It's this incredible mix of geology, data science, and even economics that secretly shapes how we get from A to B.
Yeah, it's so much more than just asphalt and steel. Our daily trip to work or school is actually orchestrated by a super complex, and often totally invisible, science that touches every single one of us every single day.
You know, this whole thing starts way before a single blueprint is even drawn. It starts with engineers basically becoming geologists, having to understand the very ground they want to build on.
And then they kind of have to become fortune tellers. They use these really complex models to try and predict how millions of people are going to move through a city, not just tomorrow, but decades from now. And it's a field that's always moving, always pushing towards a future of intelligent, connected, and yeah, even self-driving infrastructure. So today, we're going to pull back that curtain on the hidden science that shapes our world.
All right, so what does it actually take to build something truly massive? I mean, a huge bridge or a sprawling highway system. It's a way more complicated dance than you might think. Let's look at a real-world example to see how it all comes together. This right here is the Padma Bridge in Bangladesh, and it is an absolutely staggering piece of engineering. It crosses one of the most powerful and unpredictable rivers on the planet. A project like this isn't just built, it's brought to life through this really careful, multi-stage process.
You can think of every mega project like a 4-act drama. First, you've got the dream, the planning phase. Then comes the nitty-gritty blueprint of analysis and design. After that, the big show, construction. And finally, the long-term legacy of operation and maintenance.
Now this is where it gets really interesting. The whole planning part is split in two. On one side, you have the hardcore engineering problems, like, is the ground going to hold? How will the river affect the structure? But just as important, if not more so, are the non-engineering factors. Does this thing even make economic sense? Where's the money coming from? Because you can't build a bridge with just concrete, you need a whole lot of capital. But here's the thing. A single bridge or highway, no matter how big, is just one piece of a much, much larger puzzle. So let's zoom out a bit and look at the grand strategy of managing an entire transportation ecosystem. A really successful network is all about balance. First, accessibility. I mean, can you actually get where you need to go easily? Then there's mobility. What's the sheer capacity? Can it handle rush hour? And of course, efficiency. Are we getting the most bang for our buck? But lurking behind all that are these invisible forces, politics, global trade, all kinds of regulations. They all have a huge say in what gets built and where. Okay, want to learn some insider lingo? To manage a system this complex, you have to measure every tiny detail. And a great example is this term, dwell time. It's not just how long a bus is at the stop. It's every single second it takes for the doors to open, for people to shuffle on and off, and for the doors to close again. And trust me, those seconds are absolutely critical. In a busy downtown area, that dwell time can easily stretch to a full minute at just one stop. Now multiply that by every stop on an entire route, and you can see how fast a bus falls behind schedule. It really is a science of seconds.
So, optimizing things like dwell time is one thing, but what if the entire system could think? For basically all of human history, our infrastructure has just been static physical stuff, concrete, steel. But that's changing, and it's changing fast. We're now adding a layer of intelligence right on top.
This whole concept is known as an intelligent transport system, or ITS. Honestly, the best way to think of it is like the nervous system for a city. It uses all this tech to watch, manage, and optimize the flow of everything, especially as our cars and trucks get more and more connected.
I guarantee you've driven over thousands of these and probably never gave them a second thought. You know that weird rectangle cut into the asphalt right at an intersection? That's not a sloppy repair job. It's an inductive loop, a sensor that tells the traffic light, hey, someone's here.
And these little loops are smarter than they look. They actually have two different personalities. Right at the stop line, they're in presence mode, basically sending a constant signal that says, yep, a car is waiting. But further back from the intersection, they switch to pulse mode, sending these quick little pings to count the cars as they approach, helping the whole system predict the flow of traffic.
And ITS is so much more than just traffic lights. It's the little tag in your car that lets you fly through a toll booth. It's the GPS on your phone that helps you outsmart a traffic jam. It's even those advanced safety systems in new cars that let them talk to each other. It's all part of the same connected brain.
So this marriage of old-school concrete and new-school code, well, it's paving the way for the next giant leap in transportation, a world where our vehicles actually take the wheel.
Now, while self-driving cars get all the headlines, the path to full autonomy is actually playing out really clearly in other places too. Take shipping, for example. You can see this clear four-step journey, from just helping the crew to being remote-controlled with people on board, then remote-controlled with no one on board, and finally the ultimate goal, a ship that just sails the seas all by itself.
And let's be honest, we're already living in the early stages of this revolution. I'm talking about things like lane assist, automatic emergency braking, adaptive cruise control. These systems are already making our daily drive safer and way less stressful. This isn't science fiction anymore. It might already be in the car parked in your driveway.
But, and this is a big but, it's not some perfect seamless utopia. This shift to autonomy comes with some pretty serious questions. It could mean we need way more expensive, high-tech roads. It opens up a whole new world of cybersecurity risks. Some studies even suggest it could make traffic worse if we're all just sending our empty cars out to run errands. And you have to ask the tough question, who gets left behind in this expensive new future?
At the end of the day, the science of transportation has always been about moving people. But as technology just rockets forward, the most important question might not be about the road ahead, but about the person who's supposed to be in the driver's seat. What happens when the car is smarter than the driver? That's a question we're all going to have to answer together.